Okay, welcome students. Welcome to the physics class. And in this video, we are going to discuss a very important topic from your vector chapter, and that is resolution of vector. And this concept or this topic, it is very important because in the further chapters, you will find this concept is very helpful. Okay, in the complex problem, this concept will make the concept easier. Okay. So since it is a very important topic, so I will expect that you will pay attention, you will pay a maximum attention to this video, and you will try to understand what we are going to discuss. Okay. So the topic is resolution of vector. Okay. So we can start with the definition of this thing. That means the definition of this resolution of vector is that it is a process of splitting a single vector into two or more individual component. Now this definition, it is very much you can say, I know that maximum of you have not clear these things by this definition. So let's take a example. Okay, now I think maximum of you have played this game, that is carom. This is a carom board where this is the striker, these are the points, and these are the pockets. Okay, now we are targeting that these 2 points, I want to pocket these 2 points. Okay, so this point will go in this direction and get into the pocket. At the same time, this point also will go to this pocket. So I will hit one time and I want to pocket these 2 points. Okay, so I hit the striker and the striker will go straight way. So that means at this position the striker will hit the 2 point and the 2 point will go in this direction. It is very much peculiar. The striker is moving in this direction, but the 2 point is moving in this direction. This is actually the resolution of vector. This is actually the resolution of vector. That means this single vector, see, if you read the definition again, so it is a process of splitting a single vector into two or more individual component vectors. That means in this case, this vector, it is splitted into two vector, and these are the two component vector of this vector. So due to this component vector, the 2 points move in their pocket. Okay, so this is one example of this resolution of vector. Now in many situations, in many real life situations, we will find this concept. So so this is the definition, that means the process of splitting a single vector into two or more individual component vectors. So I think the definition is more or less clear to everyone. Okay, now come to the computation part. That means how we will compute the two component of the vectors. Okay, now it is a very important thing because these things only we need while solving the problems. Okay, so let's take a two-dimensional space. Now, two-dimensional space means, let's take a page, sheet. Sheet is a two-dimension thing. Okay. Now, we are going to plot a vector on this two-dimensional sheet. Okay. Now, I know that everyone has the familiarity. Now, everyone is familiar with this two-dimensional space. Now we have already done these things in our secondary level. In mathematics, we have done these things. Two-dimensional space means simply a sheet. Now we all have solved the graphical problems. So graph, we know that graph paper. So I have taken this graph paper. This is actually a two-dimensional space. Okay, so we have done this graph. That means this is a two-dimensional space. And in this two-dimensional space, we know that how to plot a point. Now, if it is asked that plot 2, 3, then what we do to plot this 2, 3 point, what we do actually is that we start from origin. This is the origin, and from the origin, now since it is 2, first is given is 2. Now first coordinate give the coordinate of along the x-axis, and second coordinate will give the coordinate along y-axis. We know these things. So first we will start from the origin. Now since 2 is given first, so along the x-axis we will move 2 unit. So 1 and 2. Okay. So we have moved 2 unit along the x-axis. Now after that we will move 3 unit along y-axis. So 1, 2 and 3. So we have moved 3 unit along the y-axis. So 2 unit along x-axis, then 3 unit along y-axis. Okay, so we have moved 2 unit along x-axis and 3 unit along y-axis. Now we have reached this point. Now this point is 2, 3. So this is the way we plot a point in a graph paper. Okay, so graph paper is a two-dimensional thing. So in a two-dimensional space, this way we take the origin, we define the space into 2 axes. That means with the help of 2 axes we have defined the space. This one is x-axis and this one is y-axis, and in this two-dimensional space we can plot a point. So to plot a point, first we move along the x-axis, then we will move along the y-axis. That means this is the point. This is the procedure how to plot a point. Okay. Now in the same way, we are going to define a vector in a two-dimensional space. Now you can see this is a two-dimensional space. We have defined a two-dimensional space here with the help of y-axis and x-axis, and in this two-dimensional space we are going to define a vector here. We are going to define a vector A here. Now same way we will define an origin. Now first we will move, now to define this A vector, first we will move along the x-axis and then we will move along the y-axis. Okay, now in this way we are going to define a vector. So it is written here, to define vector A we have to move a distance OP. So this is the distance OP along the x-axis. So OP distance along the x-axis and PQ distance along the y-axis. So PQ distance along the y-axis. So to define this we have to do this way. So OP is the x component of the vector A. So OP can be written as this OP, it is the x component of vector A. That means A suffix x. X component of vector A means along the x-axis, what is the effect of vector A? Along the x-axis, what is the effect of vector A? This is the x component of vector A, and it is written as A suffix x. See, it is written here like this. And PQ, it is the y component of vector A. That means this PQ, it is the y component of vector A, and it is written as A suffix y. So this AY is the effect of vector A on y-axis. That means it is the effect of vector A along the y-axis. Okay. So ultimately the same way the vector A can be written as AX I cap and AY j cap. Now what is this notation? See, first we are moving, that means first we are moving along the x-axis. So this distance along the x-axis, AX along the x-axis. Now the direction of x-axis, it is denoted by I. The direction of x-axis, it is denoted by I. And the direction of y-axis, it is denoted by J. So whenever I am just writing this vector A equal to AX I cap and AY j cap, that means First, we have to move the AX distance along the y-axis, that means along the x-axis. First, I have to move the AX distance along the y-axis, that means x-axis. I denotes the direction of x-axis. Then we have to move AY distance along the j-axis, that is y-axis. So, this is the way how we are going to represent this vector in the two-dimensional thing. Now, if we go for the 3-dimension, then obviously the z component will come. 3-dimension means x, y, z. That means we define a 3-dimensional space by 3 axes, that is x-axis, y-axis and z-axis. So, in that case, when we are going to discuss the vector, or when we are going to define a vector in 3-dimensional thing, 3-dimensional space, then obviously the 3 component will come. Z component will come, third component. So, this way we are going to express a vector. This way we are going to express a vector in 2-dimensional space. Okay. Now, what will be the magnitude? Now we have seen that this AX is the x component of vector, this AY is the y component of vector. And this vector A, you can see this vector A is making an angle theta with the horizontal axis, that is x axis. So this angle A, sorry, this vector A, it is making an angle theta with the x axis. Okay. Now what will be the magnitude of AX and AY? That means x component of A and y component of A. So we are going to evaluate the magnitude. Okay. So as you can see, this is a triangle. Okay. This is the triangle, and you can see that this is a right angle triangle. Yes, obviously it is a this forming a right angle triangle where this angle is theta. Now in this right angle triangle, if we are going to discuss the if we are going to discuss the trigonometric ratio in this triangle, then what it will be? See, so this is actually a triangle OPQ. This is actually triangle OPQ. This is a right angle triangle OP and Q. Okay. Now, if I am going to discuss this sine theta from this triangle, now we know that sine theta means sine of any angle means perpendicular by hypotenuse. Now, in this triangle, in this right angle triangle, what is the perpendicular? Perpendicular is PQ. This is the perpendicular. And what is the hypotenuse? That is OQ. So sine theta can be written as PQ by OQ. The same thing is written here. That is PQ by OQ. Now if we rearrange, then we can write PQ is equals to OQ sine theta. Now what is OQ? OQ is actually, it is the length, this length, the length of the hypotenuse. The length of the hypotenuse. Now this length of the hypotenuse, that means it can be also written as A magnitude. This is actually the A vector. This is actually A vector. Now the length of this length means actually the magnitude of A. The magnitude of A. We have already have the concept of magnitude. So this is actually what? This OQ is actually the magnitude of A. Okay. So OQ, it is replaced by magnitude of A sine theta. So it is written 2, and this equation is 1. Again, if we define from this triangle, if we define cos theta means base by hypotenuse. So here base is actually PO, and what is hypotenuse? That is OQ. Now PO, same thing, OP by OQ. Now if we rearrange, then OP is equals to OQ cos theta, and same way OQ can be written as the magnitude of A cos theta. So it is given the equation 3, named as equation 3. Now see, OP is actually what? OP is actually the x component of vector A, and that is AX So OP can be written as AX. Same way, PQ can be written as AY. PQ is actually the Y component of vector A, as we have discussed already these things. So PQ can be written as AY. So I have replaced these things. That means PQ can be written as AY. So PQ is replaced by AY, and OP it is replaced by AX. Okay. Now this equation 2 and equation 3, we are substituting this value. We are substituting this AX and AY in the equation 1. So in place of AX we have placed this value, that is A cos theta, and in place of AY we have placed A sin theta. So vector A, again it can be written as A cos theta I cap plus A sin theta j cap. So these are the two components of vector. So I can say a vector, I can say a vector, this vector, a single vector can be splitted into two component vector. One is the horizontal component, another one is the vertical component. Horizontal component means the component with the angle, and other one is the vertical component. So this vector can be splitted into two components. One is horizontal component, another one is vertical component. Horizontal component will contain the cos theta and vertical component will contain sin theta. So let's say this is B, then Bx can be written as, so Bx can be written as B cos theta, and By can be written as B sin theta. So a vector, any vector can be split into two components. One is the horizontal component, another one is the vertical component. Horizontal component will be B cos theta and vertical component will be B sin theta. Okay, so this is the resolution of vector. So once again, if we read the definition, so resolution of vector is the process of splitting a single vector into two or more individual components. Now this more individual component means when we think about the three-dimensional space, then three axes will come. So along the three axes, three components we will get, and this thing, this resolution of vector in the three-dimensional space we will learn in the graduation part or in higher studies. Okay. Now in our syllabus we have the resolution of vector in two-dimensional space. Okay, so this is all about the resolution of vector. Okay, thank you.